So in this video, we're going to look at combustion of carbon, hydrogen, metals, and hydrocarbons, and we're going to look at word equations for that. Now, combustion, this is burning, and burning actually is a reaction with oxygen. So combustion is reaction with oxygen. So that's the element that is responsible for burning to take place. So whenever something burns, there needs to be three things. You have the fire triangle. So for there to be fire, there needs to be three things. The fuel, oxygen, and there should be enough heat. So oxygen is the gas from air. Oxygen is from air, is the gas that is going to be responsible for combustion, for burning to take place. The fuel could be anything. So in our case, the fuel is going to be carbon, or it could be hydrogen, or it could be hydrocarbons, or it could be metals. So anything that is able to catch fire is going to be called fuel in this case here. Okay, so let's see the burning of carbon. So carbon will react with oxygen to give carbon dioxide. This thing here, this thing here, this is called a word equation. Word equation. And what does that word equation mean? This means that carbon is the product, is the reactant. So that's the reactant, and means that it's reacting with, so carbon is reacting with oxygen. The arrow means to produce, and that's the product. Okay, so that's a word equation. The word equation tells us what is reacting together to produce which product. Okay, so that's a word equation. In a word equation, you need to have a plus sign to show the reactants, and you need to have an arrow to show what is being produced. You cannot use equal to. The use of equal to is banned in a word equation. If you use equal to sign, it will be wrong. So in a word equation, there should always be an arrow. Okay, should always be there. Now, in a word equation, there's two sides. If we take the arrow to be the reference line, so anything that is on the left-hand side of the arrow is the reactant, and anything that is on the right-hand side of the arrow is the product. Or there could be more than one product as well. So you have to keep all the reactants on the left-hand side and all the product on the right-hand side. The plus sign means react with, or it also means in addition. So we're adding together. So carbon is adding with oxygen. It's not mixing, be careful, it's not mixing. This is a chemical reaction, so there's bonds that is being formed. So carbon will bond with oxygen to form carbon dioxide. Okay, so that's the product, right hand side. You have to be careful. Let's say you're writing carbon plus oxygen, arrow, carbon. You don't have space to write the dioxide. Don't write the dioxide here, because if you write the dioxide in this direction, means that you're writing the dioxide on the left hand side, means on the reactant side. And the dioxide, well, it's not a compound on its own, but the dioxide goes with the carbon here. So it's carbon dioxide, which is a compound here, which is a substance here. So the dioxide is the product, is part of the product, so it should be on the product side. Everything that is on the reactant side should be on the left-hand side, and everything that concerns the products should be on the right hand side. Okay, you have to be careful about this. And you cannot use equal to signs. You will be penalized if you use equal to signs. Use of equal to is banned here. Okay, so burning out carbon. Let's watch a little video that shows us the burning of carbon. So in this video, you have the carbon that is burning here in a very bright flame. So we use the Bunsen burner to make the carbon catch fire. The carbon was actually placed in the kind of spoon. This is called a deflagrating spoon, and it's used to hold substances so that we can actually make them burn. It's specially used to burn solids. So the carbon is put in fire. Once it catches fire, it's put in the gas jar. Now in the gas jar, there's some liquid below at the base of the gas jar that is producing oxygen. So it keeps the oxygen required for the reaction to take place. So here we're shaking the flask so that it produces more oxygen. It's this oxygen that is going to keep the carbon burning, because if there is not enough oxygen, carbon will not burn. Okay, so you see the very bright flame. So that's just to show you the color of the flame when carbon burns. Okay. Now, burning of hydrogen. Hydrogen burns in oxygen to produce water vapor. So again here, these are the reactants, and water vapor is the product. Okay, so burning of hydrogen, so that's the second one that you need to know. It's going to produce water vapor. Let's watch a video that explains that.
So what I'm going to do is fill it with hydrogen. So that's full of inflammable air, and I'm going to light the spark.
That boom that you heard, that kind of explosion, that's the burning of hydrogen. Remember in Form 1 you did that. Hydrogen burns with a pop sound. So here we have a mega pop sound because there's lots of hydrogen. So when we ignite hydrogen, hydrogen is a very flammable gas. So it catches fire and you have that pop sound, like that kind of explosion reaction.
Now, what you saw there was a chemical reaction, the reaction of hydrogen with air. And if you look closely on the sides of the flask, you'll see that it's wet. That is water.
So the water droplets, you can see the water droplets from the burning of hydrogen, and that's what you see. So the water vapor, this is what you see on the walls of that container. The water droplets, that's the water vapor produced when hydrogen burns in oxygen. The third reaction that you should know is the burning of metals. Now, any metal will burn in oxygen to produce the corresponding metal oxide. So let's see a couple of examples. So these are examples of metals that burn in oxygen to produce a metal oxide. Generally, this applies for most metals. So zinc plus oxygen will give you zinc oxide. So this is just like replacing, the product is just going to be the metal and the name oxide together. Sodium plus oxygen, sodium oxide. Magnesium plus oxygen gives you magnesium oxide. Now, let's see the burning of magnesium. It's a very interesting reaction. So, we're holding a piece of magnesium ribbon using a pair of tongs, and it's being burned in the blue flame of the Bunsen burner. Okay, and so magnesium here, as you can see, is a gray metal ribbon in this case, and it's reacting with oxygen. So oxygen, that's from the flame, so oxygen is from the air, and the flame is going to bring enough heat for the oxygen in the air to react with the magnesium, and you're going to get magnesium oxide. So this reaction occurs in a very bright flame. This is called a dazzling white flame. Dazzling white flame. And as you can see, this is giving magnesium oxide in the form of an ash. So this is a white ash. Okay, so the metal ribbon is like hard, and the white ash is going to crack and fall. Okay, so he's holding a watch glass. That glass equipment is called a watch glass, and it is placed on a wire gauze. Okay, so that's the burning of metals. Now, not all metals burn in a dazzling white flame. Different metals burn different ways. So these are a few metals that burn. You can have many others. You can have iron plus oxygen to give iron oxide, silver plus oxygen to give silver oxide, calcium plus oxygen to give calcium oxide, any metal. Last one, burning of fuels. So here, when we're talking about fuel, we're talking about wood, petrol, methane, cooking gas, diesel, kerosene. These are fuel. Paper, oil. So fuels burn in oxygen to give carbon dioxide and water. So that's the general equation. But when we're looking at fuels, there is a kind of fuels called hydrocarbons. Hydrocarbons, they are a special kind of fuel that contain only hydrogen and carbon in the molecule. So there's just hydrogen and carbon in the molecule. And when they burn, they're going to produce carbon dioxide and water, because the carbon is going to give you carbon dioxide and the hydrogen is going to give you water vapor. So that's why when hydrocarbons burn, they're going to give you carbon dioxide and water. So that's the general word equation for hydrocarbons. So any hydrocarbon, which includes methane, ethane, butane, petrol, all these are hydrocarbons, and they will react with oxygen to give carbon dioxide and water. So if I would write methane plus oxygen, I know immediately that it should be carbon dioxide plus water. Okay, so any fuel, you can replace this with any fuel, the product will still be the same. Now, you have to be careful when it's burning. Here, it's burning with excess amount of oxygen. So it's very important that you say that there is excess of oxygen in the reaction, because if there isn't excess of oxygen, the product will be different. Okay, so it's not going to be carbon dioxide and water anymore. So it's very important that you specify that it is in excess oxygen. Okay, so that's for the 4 burning reactions. So make sure you note everything in your copybook, and you're going to work out the worksheet that I will attach and will give you feedback.